Hey guys! So today we are going to talk about inheritance. So let's get into it. Now, in object-oriented programming, we see a trend that's been around for quite a while. And it's something that I think comes very naturally for the people who work in domain-driven fashion, yours truly included. And basically, the idea I see a lot of people applying is that you map up your domain models ahead of time and you create this little idea, or and UML if you want to call it that, but I usually just refer to as a whiteboard layout, where you have these different boxes and concepts that have dependencies to each other, and you basically try to map out things ahead of time, right? And I think that's great. I think that that's a very natural way for humans to think about a problem. I think you have to be careful about it, because some of the worst ideas and the worst systems in the world are things that are designed in this way. And let me tell you, I have worked on those type of ideas many times before, where someone has ahead of time tried to map out how a concept should work or whatever, and then they've sat down and actually implemented it. Now, I don't think that that's the way to go. To give you a concrete example, if you are creating, let's say, an inheritance chain, I've seen this happen many times. Usually what someone will do is that they will declare something like an entity, and an entity has an ID. That entity is then being extended by something like a user, and that user has a certain amount of properties and fields and all of that good stuff, and then you extend the user to be an admin, and then you have maybe another extension that is a customer, and then maybe from the customer you have the special customers, and so forth and so forth and so forth. It's a very common way of structuring the logic, right? Now, what I will argue that I prefer is to apply a little bit of a different mindset. And I'm not saying that this is not the way to do inheritance. I'm more saying that I would like you to take a step back, and instead of ahead of time thinking about the things that you need, ask yourself, what do you need right now? You know, this term premature optimization is thrown around a lot these days. And I would say that doing what I just tried to explain, doing this inheritance chain and ahead of time declaring your objects and your inheritances, your superclasses and your so forth and so forth, I think that is premature optimization. Or rather, the way that I like to think about this sort of thing is to allow a natural growth of abstraction to take place. What do I mean by that? That sounded really fancy, didn't it? Well, what I mean by that is that just as I sit down and write software, as I'm writing a method or a function or something like that, at that time I'm focusing on solving the problem at hand. I'm not thinking ahead of time. I'm not trying to think long term or anything like that. Not in the beginning. I'm just trying to solve the problem in the nicest way that I can. Once the problem is solved, I remove my problem-solving hat and I put on my refactoring hat, if you will. And I look at the code that I just wrote. And I start thinking about, all right, have I done this before? Is there a common thread between this software right here, this code here, and some other part of the system? If I do find that, hey, this pattern here is repeating itself, my rule of thumb is 3. If I see that I have copy-pasted or almost created the same logic 3 times in 3 different areas, then and only then will I start asking the question, should I make this into a superclass, for example? Doesn't have to be a superclass, but in the context of our little discussion here, it's a superclass. Should I do that? Should I put this one level up and allow that common functionality to be extended down to everybody else? As I said, rule of 3. If I've done it 3 times for 3 different objects, then yes, I try to create an abstraction that they can all share. there's several ways you can do this. It doesn't have to be necessarily inheritance. But what the difference here is that I argue that this allows good abstractions to grow naturally, to evolve naturally from the problems that you are solving. Because the problem with trying to, ahead of time, foresee what abstractions are going to be useful is that you don't know enough about how everything is going to play out. Only when you have written the solution to a problem do you truly know and understand the problem completely. And I think that that's a much more natural way to work, at least for me. I never try to think ahead of time if I can help it. Not too much, unless it's very obvious. There are exceptions to this rule, as you can imagine. But what I try to focus on is to solve the problem that I'm right now trying to solve as well as I can. And if by some chance or some stroke of luck, I realize that the solution to this problem is very similar to a solution to another problem that I already had, then I make a more generic solution. But I don't start off by trying to make the generic solution. Because as I said, odds are that you are going to get it wrong. Odds are that you will actually create worse code if you try to be too generic up front, or if you try to be clever before you actually have seen how, at the end of the day, everything played out. Because trust me, just as with estimating time and difficulty and so forth on any project, the reason why that is so complicated is because when you start out, before you even start working on the problem, you know so little about how all the details are going to fit together. And you need those details because the devil is in the details. So what I usually see is what happens when people go from that perspective is that they create this in their mind, beautiful, elegant solution that is going to solve all their problems. And then they start getting into these tight little corner cases and small issues that start messing up their beautiful, perfect generic solution. And instead of just scrapping the idea and accepting that they had a bad idea, they try to shim things in because they are mentally in love with their own idea. All of a sudden it becomes more about making their original idea fit the problem rather than that idea fitting the problem. Do you see? Like they're going about it the wrong way. That's what I want you to take away from this. Avoid that if at all possible. Don't try to be clever ahead of time. Write the code, copy paste it if needed, and when you see that you are repeating this pattern over and over, allow the solution to naturally grow from that instead of trying to be generic ahead of time. Have a great day.